Amazon S3. For so many of us, it's just this super simple, super reliable place to dump files on the internet. But what if I told you that its simplicity is actually one of the most incredible engineering illusions in all of modern computing? Yeah, okay, let's dive into this because what's really happening under the hood is, well, it's just fascinating.
And to really get to the heart of what S3 is, we have to start with the one question that trips up pretty much everyone. I'm talking new developers, seasoned pros, everybody. Does S3 actually have folders? I mean, it sure looks like it does when you're clicking around in the console, right? But the answer, well, it's not so simple, and it reveals everything about how this thing works. And look, this isn't just some beginner mistake. This is a real thing, as this Reddit user points out. You've probably been there. Someone insists, I need to create the folder before my app can write files to S3, and that one developer who gets it has to kind of gently explain, yeah, that's not how any of this works.
So that's our first stop. We're going to pull back the curtain on this whole folder illusion. Because once you understand this one concept, it's like the key that unlocks how S3 can operate at a scale that's just almost impossible to wrap your head around.
Okay, so on one hand, you've got your laptop, right? It uses a hierarchical file system. It has real folders inside of other folders inside of other folders. To find a file, the system has to literally walk down that tree, step by step. S3, though, totally different. It's a flat object store. There is no hierarchy. That path, x/y/z, with all its slashes, that's not a series of folders. It's just one long, single name for an object. The slashes are just characters in that name, nothing more.
But I see folders in the AWS console, you're probably saying. And you do. But it's a convenient lie. See, we humans are used to organizing stuff in folders. So the user interface just pretends they exist to make our lives easier. It looks at all the objects that start with the same prefix, like images, /, and it draws a nice little folder icon for you. But underneath it all, it's just one giant flat list of names.
All right, so if it's not folders, what is it? Amazon actually gives us a really great analogy to build a mental model here. I want you to stop thinking of S3 as a file cabinet and start thinking of it as a massive, infinitely large library for all your data.
So first up, you have the object. In our library, this is the book itself. It's your actual data, the photo, the log file, the movie. And it also comes with some metadata, kind of like that little card on the book that tells you who published it and what it's about.
Next, you need a place to put all your books. That's a bucket. Think of it like a whole section in the library. The art history section or the science fiction section. It's that top-level container that holds all your related objects together.
And finally, how do you find one specific book in that giant art history section? You use the key. This is the card catalog entry. It's the unique name of your object. So the bucket name plus the object key gives you the exact location of your data instantly, no searching required.
Oh, and this isn't some public library where anyone can just waltz in. No way. By default, everything is locked down tight. You need the right permissions, the right library card, if you will, to even get into a bucket and look at the objects inside. This security-first approach is absolutely fundamental to its design.
So that library analogy, it's a great start. But now we're going to peel back one more layer. We're going to look at the true technical architecture, the engine that lets S3 work at its frankly mind-boggling scale.
So here's the crucial takeaway. At its core, S3 is just a gigantic key-value store. That's it. You have a key, that unique name of your object, and you have a value, the data itself. This incredibly simple, flat model is exactly what makes it so unbelievably powerful. And this quote from someone who worked at Amazon just illustrates the design philosophy perfectly. It's a fascinating insight. You see, Amazon's famous Dynamo paper laid out the principles for a super scalable, highly available key-value system. And while the service we know as DynamoDB is based on it, this user suggests that S3 is an even purer implementation of those original powerful ideas.
So why is this architecture so important? One word: scale. As of 2021, Amazon S3 was storing over 100 trillion objects. 100,000 billion. I mean, just let that number sink in. That's roughly the same number of synapses in a human brain. It's just immense.
And that brings us right back to folders. A traditional file system, one that has to traverse a tree structure, would literally collapse under the weight of 100 trillion items. It would be impossibly slow. So the flat key-value structure, it's not just some random design choice. It's a physical necessity to handle that much data.
Okay, now for the really cool part. We're going to take a rare peek inside a single S3 storage node and see the incredibly sophisticated engineering that makes all of this work. And this is based on a research paper that came from the S3 team itself.
So S3 is built from hundreds of microservices, but way down at the lowest level, your data lands on a storage node. A modern version of this is a system called ShardStore. And this isn't some simple program, okay? It's a highly complex piece of software with over 40,000 lines of Rust code dedicated to doing just one thing: storing and retrieving key-value data as reliably as possible.
So how does it actually write your file to a physical hard drive? Well, it's basically a three-step dance. First, your object gets broken up into smaller pieces called chunks. Second, those chunks are written sequentially, one after the other, onto disk regions called extents. And third, and this is the magic part, a highly optimized index called a log-structured merge tree, or LSM tree, gets updated. Just think of it as a super efficient table of contents that's built for insanely fast writes. This tree is the map. It knows exactly which key points to which chunks on which extent.
All right, let's wrap this up with the philosophical core that makes S3 one of the most durable systems on Earth. It's all about engineering for failure.
You know, most systems are designed with the hope that hardware won't fail. S3 is designed with the absolute certainty that it will. Hard drives will crash, servers will lose power, networks will go down. The entire system is built to treat failure not as some kind of rare exception, but as a normal, everyday part of life.
And to manage this constant state of failure, S3 relies on something called crash consistency. What this means is that the order in which data gets written to disk is meticulously controlled. So if a server just dies mid-write, the system guarantees that when it boots back up, the data on the disk will be in a predictable, non-corrupted state. It might have lost that very last incomplete write, but it will never, ever be garbage.
And all of this brings us to one of the founding design principles of S3. This quote, it just perfectly captures the entire journey we just took. From the outside, you see a simple service with folders, but underneath, you have a massively complex, 100 trillion object key-value store built on the assumption of constant failure. It's as simple as it can possibly be for you, the user, but not one single bit simpler in its engineering.
So the next time you drag and drop a file into what looks like a folder in S3, you'll know. You'll know about the incredible iceberg of engineering hiding just beneath that simple surface. Which really just leaves us with one final thought. What other technologies that we use every single day, the ones that feel completely simple, are hiding this same level of mind-bending complexity?